We're learning about binomial products and applying them to surds. Binomial products, in my opinion, is extremely important to identify and be able to demonstrate skills in maths because not just with surds but with regular algebra as well, you'll see them. So this is an important video. So we've got on the left hand side of this line, we've got an area made up of some smaller areas, and we're going to demonstrate the pattern algebraically on the right, and I'm going to do that about 4 times, I think. So basically, this firstly, what is a binomial product? Well, an example would be a plus b is a binomial term or expression. A different one would be c plus d. Bi meaning two terms. You can see that there's 2 terms there, there's 2 terms there. The product means multiplying, so even though we don't write it, each of these binomials is multiplied by another one. You might have seen this pattern before with regular numbers, real numbers, and in your studies of algebra so far. Before we get carried away with the algebra, if we had to find the area of this whole shape, it'd be made up of 4 rectangles. Do you like my colouring in? Okay, 1, 2, 3, and 4. Yeah, I didn't really put a huge effort into that colouring in, but I think you get the idea. So we have 4 areas, and they're rectangles, so we go length by width. So the first rectangle in green here, its area would be A times C, which I'm just going to write as AC. And then the one on the top right is AD. The one on the bottom left is BC. And the one in the bottom right is BD. Okay, so we've got AC, AD, BC, and BD. And that's actually the result of this binomial product. Now, all of these 4 areas here come together to add to the total rectangular area of the bigger shape. So we have to add them, don't we? So AC plus BC plus AD plus BD. Now there's another way of getting that, and some people like to call it by an acronym called FOIL. Oops, I forgot the I. First, outer, inner, last. First by first, first by second, second by first, second by second. It'll get us the same result. If you look at that, and this is basically an extension on the distributive rule. First by the first, first by the second, second multiplied by the first, and the second multiplied by the second, and each of those results get added up, and that will give us, if you have a look, that will give us the same. So first by first will give us AC, first by second will give us AD, second by first will give us BC, and lastly BD. So that gives us the same result, and we're going to use that with surds. So here's an example. 4 plus root 3 multiplied by root 3 minus 2 there in blue. It's a binomial product because it has that 2 binomials multiplied together. 4 plus root 3 is a binomial, root 3 minus 2 is another binomial, and you can see them multiplied together. So whether you think of it in terms of an area or the FOIL type pattern, you need to be able to multiply and add using your existing skills. So expanding out through multiplication and addition, we have first by the first, if we're using the algebraic pattern, 4 times root 3, and that's 4 root 3. Whoops, I'm getting my colours mixed up. Now the first term by the second. Be careful that, maybe you've seen this from your algebra, that minus there can be rewritten as plus a negative if you prefer, because that way you know that that has a negative effect when we take the product. So that's 4 times negative 2, which is negative 8, or in other words, minus 8. Okay, if you studied a bit of distributive rule for your algebra in the past, you probably remember that. Okay, second by first, root 3 times root 3. written there. And the last term, remember, it's got that negative 2, so our root 3 times negative 2 is minus 2 root 3. Let's simplify. Because I have my existing skills, I can identify that there's some like terms there. In the maroon, I've got the root 3's and the surds, multiples of root 3, and then we've got the integers or whole numbers there with the purple colour highlighted underneath them. So we have 4 root 3 minus 2 root 3, and we have minus 8. Now root 3 times root 3 is 3, because it's the square root of 3 squared. So we have 2 root 3. Now minus 8 plus 3 is minus 5. So we have 2 root 3 minus 5, and that's simplified. Okay, we have a different pattern for the second one. So if we have a big rectangle and we split it into that, and it's not cooperating with me, click. Okay, so this pattern here being different, across the top we've got an A and then a B. So the whole top would be A plus B, the whole top of the rectangle. But down the left hand side is also A plus B as well. So it's actually a square. Okay, now my drawing's not the best. That looks like a rectangle, doesn't it? But across the top, if we just look at the values there, it's A plus B, alright, across here, and A plus B down vertically as well. Okay, so perhaps I should have made it look a bit more square. Now this one, the overall big rectangle, length times width, would be A plus B across and A plus B down. It's actually a square, so side by side. We call this A plus B all squared. Okay, that's how the pattern is known, and that's basically tied in with the expansion of a perfect square. So that one's got a name. We're going to expand it, expansion of a perfect square. Okay, so perfect square. So what we do is look at the areas here. We'll do what we did last time. So that area there would be A squared, A by A, that's AB. That one is BA, or same as AB, and that one's B squared. So what we've got basically is the sum of all those, and that would be A squared plus, now we've got AB there 2 times, BA, AB, it's the same thing. So we have 2 lots of AB and B squared there. And that's the expansion of a perfect squared. A plus B all squared is A squared plus 2AB plus B squared. That is really an important one and very handy with surds, but also with algebra and other patterns in general. If you study any sort of level of maths that's even mildly advanced, you are bound to come up against that one quite a lot. Here's an example involving surds. So we have an A plus B all squared situation there, where 3 root 2 is the equivalent to what was called A, and 5 root 3 is equivalent to what's called B, and we just follow the pattern once we know it. Okay, and the diagram explains to some degree, visually at least, or geometrically, why the pattern works, and it's a matter of being fluent with the pattern. Okay, so I know the pattern, so it's A squared, which is 3 root 2 squared. Now, brackets around everything is my advice there. 2 times, putting a times sign in there, A is 3 root 2 times B, I'm putting another times sign in there, multiplication being shown, and then B squared, it's added on the end there. Okay, so index laws, when you square something like this, both of those terms are squared. Same when we get to here, something to remember. So 3 root 2 all squared is 3 squared times root 2 squared, which is 9 by 2. We'll simplify that further on the next line. Here we have 2 by 3 root 2 by 5 root 3. Now all of these things here from our previous work, they're all multiplied together. We can change the order around and still get the same result because of commutativity. So we have 2 by 3 by 5, which is 6 by 5, which is 30. And we have root 2 times root 3, which is root 6. Now, you have to be fluent with your previous knowledge. If you didn't know that root 2 times root 3 was root 6 from your previous work, you'd be a bit slower at this, wouldn't you? And the last one there, 5 root 3 all squared is 25 times root 3 squared, which is 3. And we have 18. Now I'm going to move 25 times 3 is 75. I'm going to move that over there, plus the other different sort of term, 3 root 6, putting that over there. So that's 93 plus 30, I might have said 3 root 6, I meant 30 root 6, and that is simplified. So looking at the third out of 4 patterns, this one's very similar to the one we just did. What if we didn't have a plus sign there? What if it was a subtraction or a difference? So we have a minus b all squared. And how do we draw a picture of that? So in other words, I'm asking what does this expand out to? We just did a plus b all squared. What about a minus b? Well, we need a diagram perhaps, and if we call all of this time across there, right the way across, call it a, and it's a square, so this is going to be a as well. Now, how do we get a minus b? Well, we have to subtract a quantity. So from the vertical a, I'm subtracting b off there. So we would then have here a minus b. This pink color is the distance or the dimension a minus b. We need to do it across as well. I'll put that in there. So we've got a minus b across. Now what we're finding is the result of a minus b times a minus b. So let's identify that, a minus b times a minus b, which would be that by that, so that would make it that area there. Okay, yep, I don't really care about the quality of my colouring in right now. How did we get it? Well, we started with the big rectangle, so that's a by a, or an a squared. Then we started taking off a couple of other things. We took off the strip along the bottom, we subtracted that off, so that area there. Now what is that area down there? Well, it's a across and b high, so we took off a times b, or ab. We also took off the strip along here vertically, right down to the bottom. Now I'm about to go over this strip that I've already taken off. Look, I'm taking it off twice. That's not okay. I'm going to write down the minus a by b bit. Now we've taken something, that's right so far, except that I've taken this zone off 2 times. That's not right. I wanted to remove it once only, so I'm going to have to put on this little area back on. Now what is it? It's a little square of b by b. Alright, you can see the b height on the right side, so it's b times b across, so that's b squared. And so we've got a squared minus 2 lots of ab plus b squared, and that's the expansion of a perfect square when we've got the a minus b. Notice that really overall between those last 2 ones, if you write it like that, you've got them both covered. A squared, if it's plus you write a plus, if it's minus you write a minus, 2ab, it's always plus b squared on the end. Okay, that one's always positive on the end. So that will cover both of those middle 2. Okay, I'm not going to do an example of that because it works just like the previous one to keep the video reasonable. Last one here, we've got a there and added on b there, and we've got another A going down the side, and then we've subtracted B off. I probably should put my drawing better proportion like that. There we go. And so we've got A vertically as well, and then we've got a little B subtracted there, that vertical distance there. So that makes this part here vertically A minus B from there to there. Okay, and it's A like so. So we have another pattern. This is the final one. We want to know what this area is. Okay, well, algebraically it would be across the top. The rectangle would be A plus B, and vertically it would be A minus B. You can see there in the orange, and that's another important pattern. The name of this final one is forming the difference of two squares by expansion. So we're going to do expansion, and the result we'll get will be the difference of two squares. And you can see that relates to the drawing there. So how do we find the area? Well, what's this area at the top left? It's A across and A minus B vertically. So it's A times A minus B, which is A squared minus AB, and this one here is B times A minus B, which is AB minus B squared. So let's add those two together. We've got A squared minus AB plus AB minus B squared. Now these two in the middle are equal and opposite, so they come to 0. So all we've got is A squared minus B squared, and that's the difference of two squares, A squared minus B squared. So that's the important result. So that expanded out will give the difference of 2 squared, A squared minus B squared. Let's look at a final example. So we have 7 root 2 plus root 3 times 7 root 2 minus root 3. Now it's worth learning this last one here because it actually is faster than doing it foil. You go like the first pattern. Take you a lot longer. This is really quick, so it's worth the effort. So what we do is get the first term. It's common to both. See, we've got A and A. We've got B and B. Let's get that first term and we square it. So 7 root 2, and we square that. Now it's always a minus, because we saw that with the pattern that we formed, so it's minus, whoops, sorry, that should be a root 3. Just grab the term itself, forget about the sign in front of it. Last step, we have 49 times 2 minus 3, 98 minus 3, 95. That's a lot quicker than using foil. So I know that was a long video, but that's very important, all of that, those 4 patterns for algebra, but also for surds.